Hello, Lucia. Welcome to the stream. We will continue yesterday's stream. Yesterday we solved this one, the first one, starting from 2500 rating, the maximum genetic difference query. Nice, the first problem was very useful. Yes, we learned how to use a try data structure of bits to find the value in a set that results in the maximum XOR. Okay, so yes, it was an interesting one. So then we went on to solve this one. Let me share the link. And it's called the maximum sum queries. And you're given two arrays, nums1 and nums2 of the same size n. And you're also given queries which consist of an x and a y coordinate. And for each query, you want to find the maximum value of the sum of nums1 of j and nums2 of j for some j, such that nums1 of j is greater than or equal to x of I, and nums2 of j is greater than or equal to y of I, or minus 1 if there is no value satisfying the condition. And I started thinking about this, so I made this diagram. So you can think about the values as points in the 2D plane. And so we're asked to find, so for a query x of I and y of I, we want to consider only the points in this quadrant on the area highlighted in red. And then out of those, we want the one with the maximum sum. So I think the idea here, so one thing that I mentioned yesterday is that one usual trick to do this is that we can go, well, this is a, so you can sort the points, right? And we can go from largest to smallest. And in that case, we can add the points to a data structure, the ones that we have processed so far. And then that means that we're gonna have all the points that have an x that is greater than or equal to the query. We already are going to have them in the data structure. So then we can forget about this requirement, right? Because all of them are going to satisfy this. But then we want them to satisfy this condition, the condition of being greater than or equal to y of I. And I think one trick to do that is to have a data structure, a segment tree, right? Because remember that a segment tree, you can think of a segment tree as an array, as a special array, a magical array that has that you can add some, you can get quickly range query, but it's useful to think about it as an array, right? So let's say that we have our values here, and so we care about all these points, right? The points that are highlighted in red. Well, I mean, actually, we're gonna deal with all the points, even the ones that are here. All the points that are to the right of x of I. And so we're gonna add them in a, so this starts at 0 and it ends at some n minus 1. And so what we're gonna do is we're gonna index this array by y, right? At the y point, we're gonna put the point. So let's say that we're considering this point, right? So this is x comma y. And so at y in this array, in this special array, we're gonna add the value. We're gonna put the value x plus y, right? And so now when we want to solve the query, right, we go, we're gonna ask for the maximum in a range, right? So we can ask for the maximum in this range, in a suffix, and we can do that quickly if this is a segment tree. And that should give us the maximum x plus y that satisfies the condition. But the only catch here is that I think the coordinates can be up to, yes, they can be up to 10 to the 9, right? So y can be up to 10 to the 9 inclusive, and I think it's the minimum value is 1. So y is in this range. So what we can do to deal with that is to do what's called index compression, which is just a fancy name to say that we get all the values of y that we have, and we sort them and we remove duplicates, right? So let's say that we have not the index compression. I mean, this is a simple contest. I don't know why you're afraid. It's like you're afraid of topics. Like, so for example, let's say that you get all the y for a given input. You say, let's say that all the y so you have 5. So these are the total, the possible y's, ordered, sorted, and so let's say you have a 10, and then you have this value, and then maybe you have even this value, right? But it's very simple. Don't worry about it. And so now we assign indices here. So this becomes, so we're doing a 1-to-1 mapping, right? So this becomes 1, this becomes 2, this becomes 3, and so on. And now we can use the array, right? And it's very simple. You just have to, so we have to get the y coordinates from both, from the points and from the queries. We wanna have them all, right? And then you just put them in a set. So we have the y coordinates and the y queries, let's say. We add them to a set, we sort them, and we enumerate them. And we create a dictionary of so the index and the value, right? And then we make a dictionary from the value to the index, right? So this is going to be our IDX. And so just with just this line, you create the index. So then when you want to, before you access the segment tree, you translate the value to the index, right? But the value, so this is going to be the index, but the value should be x plus y, right? It should be the actual, the real value, because we want to get the maximum of that. So in that case, we do care. We do care about the quantities, not just the order. So yeah, I think this solution is good. We're gonna be coding a segment tree from scratch so that we review how it's done. So let's call this x's and y's, and these are our queries. And so we want to do what I just said. We want to get the dictionary of the indices. And so this is going to be from x to y to I, and enumerate of sorted and a set. And here we want the y's, and we also want, so for the queries, we want the y's of the queries as well, right? So now we have our index dictionary. And now we also want to have our data structure. Yeah. So remember how I'm gonna explain it. So we want the segment tree. And how do we do that? Yeah, we want a size. We want to have the size of the segment tree that is going to be the number of different values that we have here. That is going to be our n. And so remember, so it's useful to have the base be a power of 2. So while this is less than n, we multiply. So we find the smallest power of 2 that is greater than or equal to n, right? So that's going to be the size of our array in the segment tree. And now what do we do? Okay, so we create the tree of size twice the base, right? Because we want, on the one hand, to represent all the elements of the array, but we also want the internal nodes of the. Remember that the segment tree is a complete binary tree, a perfect binary tree in this case. And so the number of nodes in the last level is roughly the same as the number of internal nodes in the tree. And so let me refresh this a little bit. So let's say that we have this array of of size 8, or yeah, let's make it small. So 4 elements. So that means that we're gonna have an array. So we can write it this way. Yes. It's not exactly that. Is 2 to the I minus 1. Because notice that the number on the left is odd. The number of the right is even. So you have to subtract 1. Okay, so this is our array. So remember that we're gonna have a segment tree, which is going to look something like this. So if we have, so let's say that we have the values, I don't know, 5, 2, 1, and 10. And so this is going to be a segment tree that keeps the maximum, right? Because we want the maximum of x plus y. And so here in the intermediate nodes, you save the maximum. So here the maximum between these two is 5, right? The maximum between these two is 10. So you put 10 here. And the maximum between these two is 10, right? So now when you want to solve, and notice that the indices in our, so this is going to be at index 1. This is going to be at index 2, 3, and then the index of this is going to be 4, 5, 6, and 7, right? So we need, as I said, we need an array of size 8, which is n times 2. And so when we want to get the maximum of some range, right? For example, hey Roses, thanks for the raid. Welcome guys. We're solving hardest problems in LeetCode, starting from 2500 rating. And we're reviewing, I'm trying to explain them from scratch. So we're reviewing how segment tree works, because I need one for my solution. Hello whale. So remember, when you have, if you want to find the maximum in this range, right? You have one index for the left part, the left side of the range, and the right side of the range, and then you go up, right? But when you go up, you want to make sure Yeah, maybe it's better to explain it. Yes, to have R here. So we want the maximum in this range. So we want to move up on the we want to go up the tree, right, up to the root, or until we need to. And so here, but if we move up, if we move to the parent of this node, then we're going to include this element here, right? Because this is a children of this node. But this element, the first 5, is not in our range, right? What we do is we consider this value, which is 2, right? We consider, okay, we seen 2, we keep it as the current maximum, so the maximum so far, and then we move L 1 place to the right. Strike on bro, what's up? So we move left, the left pointer 1 place to the left, and now we go up, right? And so now they are both here, and we keep doing that until we are done. Because, yeah, we can move up, so we can ignore the 1 because we go to the parent, which includes both of them, and we already have computed the maximum for that in the intermediate node, in the internal node. And so that's how this works. So we first created with zeros. We use 0 because we care about the maximum, and all these values are positive. So the 0 is going to be it's not gonna affect. We could set, I guess we could set minus infinity as well, but it doesn't matter. Okay, so then we want to be able to set a value. So we want to set at index I for value x, and notice that we have to translate the index first, right? Because this is an index in the logical array, if you will, right? Which the 5 is at index 0, then the 2 is at index 1, and so we have to add what we call the base of the segment tree, which in this case is 4. And so that means that if we want the index 0, we add the base, which is 4, and we get to 4, which is the first element. So that's what we do here. And now we update. We set the x value, the new value here. Then we want to move up. Remember that if we divide by 2, the integer division, we go up to our parent. I have an interview next Friday with Amazon for a junior software engineer position. Which data structures would you recommend practicing to prep myself? So what is? Have you studied DSA before? Do you know? I think Amazon. Oh, so you do know. So you want to refresh some. I think they give an OA in Amazon, which are, I think, are usually like mediums, LeetCode mediums. But so what I would recommend you is to maybe find some of the, if you already know and you want to do a review, you can search for some of the lists, like LeetCode's list, and go over the list and try to, if you already know, you can do a review and see what you know and what you don't, and try to focus on what you don't know. So you have a week, so you can study, I guess. But yeah, those lists are usually the problems are selected, so they are common topics that come up in Fang interviews. So that could be a good way to accelerate your preparation. Oh, you're in the final round. So you already did an OA? You might, okay. Best of luck. But yes, if you're gonna, if the two more interviews are DSA interviews, they do 4 phases. If they are DSA interviews, I would go over the LeetCode list and try to review the things that you know and try to study the things that you don't. The application, the assessment, phone screening, and something called Amazon Loop. Yeah, I'm not familiar with. You do technical and behavioral questions. Yeah, I mean, I was assuming it was your interview was data structure and algorithms. I mean, because that's what you asked. Of course, for behavioral, you can look up for the kind of questions that they ask and try to think about what your answer would be. Anyway, so let's continue. So we go. So remember that dividing by 2, the integer division is going to give us the parent. So we go to the parent, right? So and now we want to keep going up to update all the internal nodes that are affected by our change, right? So this means that, remember that the root of the tree is at index 1. So while we're still in the tree, we want to update the internal node by getting the maximum of the children, right? We want the maximum of the children, and then we move again to the parent, right? So this is our code for setting a new value, and then we have the code for getting the max of a range. For behavioral, prepare examples of teamwork, the company values. Yeah. So here we have our L and R pointers, like I said before, and so we have to first translate them into the indices of our array, and we're gonna have the maximum, and while we still have a range, we want to check if L is pointing to a right child, which means that it is odd. In that case, that means that we have to increment it, and before we incremented it, we have to take the max of that value. Right? And the same thing for the right side, but now we want to check if it is a left child, and it is a left child if it is even, and in that case we get the value, we consider that value, and now we subtract 1, we shrink our range, and now we move both to the upper level, to their parents. 2 divided by 2, okay, and yeah, let's set minus infinity instead of this. I think makes sense. Yeah, so now we have our segment tree. So we said that we wanted to sort by x coordinate. So one trick to do this is to do zip of both lists. Then we sort by the first coordinate, and then we zip again with this. That's what it does, is it unzips, and so now we have them in sorted order. And so how do we do this? So we want to go, we have to return the queries in order, right? So we also want to sort the queries by x, by the x coordinate. So what we can do, so one trick to do this is to define the order, but have the indices, right? And here we get, so we sort by x, yes, by x, and yes, maybe reverse. And so now we're going order, now we're going over the queries in the in this order. So we have x query and y query are going to be queries of I, right? So we have to define our segment tree of size of the length of the indices of I, of y, and so we want to get the maximum in the array from the index of y of the query, and to I didn't follow why we reverse the queries. Oh, no, we reverse both. We reverse both. I guess you're right. I could do it this way. I mean, it doesn't matter. I was going to have, so here I need to have an index in this arrays, and so now before I do this, I have to make sure that so I need to have some I want to make sure that I have added to the data structure all the points that have an x coordinate. So if x is less than or equal to this, then we want to add this point, and we want to increment j. So we want to add this point. What does that mean? It means that we want to set on the index of y j the value yes, but I guess here we have to be careful because we only want to set it if the value is greater than whatever we had. So how do we want to do that? Let's call it update. Let's have another. So let's say we update this value. Yes, exactly. If the sum is greater, we want to, because we could have more than 1 points with the same y, and we want to only store the one that has the greater sum, the greater x it would be. And so we do that. If we do this, I think we need to implement this update thing. And now we want the max from here to the end, right? And this is going to be the answer of our query. Or okay, so we have to set -1. So I think we can change this, all the infinities, to -1, and it's going to work out. Because again, all the values are positive. So if the maximum is -1, it means that there was no value there. So that's what we want. And And what is missing is this update method. So here we want to if x is greater than yeah, maybe we don't, if self tree of this, only in this case we want to do the set. So here we do set of ix. That should work. I think that's all we need. List index out of range. Oh, this is not n, this is len of queries. Yep. This is not going to be easy to debug, I think. So I mean, we got the right answer in this too, but not on the last one. Should be example 1 in the problem statement. Yes. Yes, we have an explanation here. So for maybe we can draw it so that we understand what's going on here. Let's see. So our nums are so the first point, so we're gonna have 1, 2, 3, and 4, and then here let's say this is 9 and this is 5. It's not in proper scale. Okay, so first we have the point 4, 2. 4, 2. Then we have 3, 4, which is here. Then we have 1 and 9. Which is here. And then we have 2 and 5 here. And the queries, so the first query is this one. So, okay, so in this case, the only point that we care about is this one, so that's why the answer is 6, because yes, because the point is 4, 2, so the sum of the coordinates is 6. But here we had 1 and 3. So 1 and 3. So we have to we only exclude this point. And so I think the maximum in this case it's going to be 10, right? Because this point is the one that has the greatest. And now for this one, for 2 and 5, yeah, for this one, for 2 and 5, we only have this point, right? So the answer must be 7. And what was our answer? We answered 10. So it seems that we considered this point here we consider this point here. That's very odd. Oh, I don't know why. What the hell? This 0? What's this 0? It's I and 0. I think that's the bug. Yep. All right. All right. We got it. Lol. Yeah. Yeah, it was a typo, I guess. Silly bug. Nice. Thank you. So maybe I can update my how do I update this? Now we have 2 solved. Cool. Should we do another one or 1 second? I'm back. So okay, so this one was a nice one, I think. What was the first one you solved? I solved this one. So I'm going from the 0 track list. I set the minimum rating 2500, and I just started from there. So this one is the first one, but then I skipped. I don't know why I skipped this once. Maybe I solved them before. So now I did this one, I think. And the third one is going to be this one. Why did I skip this one? Oh, yes, I solved this already. And yeah, it seems like it involves, well, it's pretty long code. Try the hardest one from this list. What do you mean, the hardest from this page, or what? Or like the hardest of them all? So in this page you have all the contest problems. I think there are like less than 2,000. The highest rating. No, I'm just starting from, I think 2,500 is a good difficulty for me. So I'm just working my way up from here. So this one required binary lifting. I think I did so in my official account, I only participated in one contest. I got 26th. But don't worry about my rating. I think this is a good starting point, let's say. So I'm gonna read this one and see what I can do. See if I get an idea. Are you a competitive programmer? Not anymore, I guess. Now I'm focusing on LeetCode. I mean, depends if you consider LeetCode contests as competitive programming. Substring with largest variance. The variance of a string is defined as the largest difference between the number of occurrences of any two characters present in the string. Note that two characters may or may not be the same. Okay. So they are the same only when there's only one unique character, and in that case the variance is 0, I guess. Given a string S consisting of lowercase English letters, return the largest variance possible among all substrings of S. A substring of is a contiguous So of course you can't do a quadratic, like going over all the substrings, which is usual for hard problems. So it seems, I think I saw this one before, because I'm remembering. So it's hard to find problems that I haven't seen before. But yeah, maybe we can do it anyways too, because I haven't solved it with this account. So yeah, I think that the key here is to realize that there are, do it anyways because we never saw them. Yeah. I don't really understand the problem statement. Okay, let's see the example 1. So here the variance, so here they are classifying all the substrings. So here the variance is 0. Right, because yes, if you have only one kind of letter, so you have all A's, then the maximum and the minimum frequencies are the same. So that's 0. So it's the difference that determines the variance from the maximum minus the minimum. But if you have two letters like A and B and they both occur the same number of times, then again the maximum and the minimum are the same. So it's all of this have 0 variance. And here you have variance 1 because you have 2 A's and 1 B, or 2 B's and 1 A. We only care about the frequencies, not the values. Yeah. That's right. And here you have two. Yeah, I mean, this is a special case because you have only A and B, only two different letters. Well, and here it's 0 because in every substring, every letter occurs 1, so the maximum and the minimum is going to be 1. And so the variance is always 0. And so is it clear now what it's asking? So I think you could you could use the fact that there are only 26 letters, right? So let's say that you're considering A and B, right? You can try all the combinations of two letters, right? So if you have only one letter, of course the variance is going to be 0. So you don't have to consider them. But if you have A and B, then you only care about, like, let's say that you have A, then B, and here you have some other letter. Well, let's not even. You have some other letter here, but you don't care about them. And you want to find the substring that has the maximum number of A's and the minimum number of B's, right? Let's say that you choose them in this order. So let's say these are pairs, and you want to find the maximum occurrences. So you want to find a substring with the maximum number of A's and the minimum number of B's, right? To maximize the variance. And so I'm remembering it's funny because yeah, I can't help but remember what I did before. So I think what I did was, so you can ignore this. You can create a new array, right? So all the groups of A's, you're gonna take them together, right? It doesn't make sense to stop it doesn't make sense to break down a group of A's, right? You want to maximize A's, so you're going to take them all together. So you can just count consecutive groups. So here you have a 3, here you have a 1, and so these are positive. And then if you have a B, you can add, well, this is positive. So then if you have a B, you can add a -1, right? And now, and then let's say here you have 2 A's, so this becomes +2. And now the problem kind of turns out becomes mass of array sum. So remember this problem. This is one of the classics. where you have some array with integers that can be negative, of course, and you want to find the maximum sub-array sum. And so the solution is to say, so let's say you want to find the maximum sub-array sum that ends at 3. So it either has it's only the 3, right? Or it contains also the 2. And so you have a recurrence, right? You want the maximum between 3 and whatever let's call it dp of I minus 1, right? The maximum sum ending at the previous value, right? So this can be solved in linear time. But here there's a catch that your sub-array must have at least 2 elements, because so you don't want to get all A's, right? Because that's not good. You need to have at least one B, so that this is a sub-array that contains A and contains B. And so that means that that's why I'm setting the B's separately. So if we have a group of 3 B's, I don't want minus 3. I want -1 and -1 and -1. Because it's not true that you want to grab all the whole set, the whole group. You might want to grab only one of them. Yeah. So you have to do the max sub-array sum, but with at least 2 elements. So let's see if I can do it. So we want X to be one of the letters, and Y to also be one of the letters, and we want them to be different. Okay. And we want to find a maximum, so let's initialize it with 0, right? And now we have to transform the string, taking into account these 2 values, by getting the streaks of X, ignoring anything that is not X or Y, right? So, and this is going to give us an array, and then we want the max sum of A, and that's going to be our our variance, our maximum variance. So how do we do the translation? So we want to keep a streak. We want to keep a streak of x, right? So we're gonna go over the letters, and if we find something that is equal to x, we're gonna do something. So we find an x, we want to increment the streak. If we find something that is not, and we have a streak, then we want to append that streak, and we want to reset it. And here, if we have a y, we want to append -1. And in the end, if we have a streak open, we want to also append it. And so I think this should do it. This is our translation, our transformation of the. We ignore anything that is not x or y. We add -1 for y. And we group all the consecutive x's. Okay, so now we want the max sum of an array. So far, so good. Okay, thanks for paying attention and validating what I'm doing. Yeah, I don't know. Maybe there's a simpler way to solve this one. I think it's neat to reduce it to such a known problem. Okay, so now, yes, I like it. Thanks. Okay, so now we want to find the max of array sum. I think this one is a little tricky, right? Because we have to let me think. No, I think we can first get the max sum. Well, let's call it dp. I don't like that name usually, but it's okay, I guess. So let's first find the max of array sum for without having the restriction of having 2 elements. So the cur is going to be the maximum between, so we're considering the sum that ends at a of I, and we have to have at least one element, so it will have a of I. And then we want the maximum between 0 and the previous value, which is cur. And so this should be, and we update this with cur. Okay, so this is going to give us dp is going to have the maximum sum that ends at I. And now what we want, I guess we can do it, we can even do it here, but yes, never mind, we don't care about. So we want the maximum sum that has at least two elements, so we start from the second. And we want we are going to have a of I if it ends at a of I, and then we want the maximum sum of the previous that ends at the previous one. It has at least one element. And this should be it. Least assignment out of range. Oh, this should be like this. Okay, we passed the examples. That's interesting. Do we submit? Go for it. Okay. Oh no, wrong answer. I mean, we passed a lot of them, huh? TLE? No TLE. No TLE. This is fast. But we got a wrong answer. How do we debug this? How do we debug it? And it was so... Okay, so we found something better than the answer, so that means that we have a bug. It's not that we're not finding the optimal. It's not that our algorithm doesn't find the optimal, at least by this example. So how do we debug this? Well, maybe we can review it a little bit. Or, well, what if we use this test case and we print something? So let's see when we find 6. So let's print this x, y, and a. If we find the maximum. Okay, we found it many times with W. With dub. Oh, whoa, I know what's wrong. Yeah, I don't have to end the streak. So I have to completely ignore anything that is not X or Y. So here I only do this if right. I only do this if I have a Y, right? But is that if I have any other character, I just ignore it. I don't care about them. So let's see what happens now. Okay, we got it right. We got it right. Nice. Nice. Why did that bag find something better though? That's a good question. Yeah, I think no, I know what it is. Because the restriction of having at least 2 elements can be. So we set the restriction of having at least 2 elements in order to make sure that we have at least one y in our. But if we break down the x's, we can grab only x's and no y's, and we have a better variance. But it's fake because we have a y. We don't have y in our sequence. So yeah, this is a pretty interesting problem. I think this is I like this one. Easy clap. Thank you. Yeah, and it's not slow. Right? All right, let me update the counter. So we're now at 3 solved. And we're getting there. Now we're only missing 70 out of the 73. Well, maybe I can count this one. Maybe I should count this one because I've solved this one before. So I'm gonna count it. Don't cheat. Yeah, I don't want to solve problems that I have solved here with LeetCode. Solve them again. Stream mode, it didn't happen. I don't know about that. And what about this one? Well, actually, it's funny that you say that about the stream, because I might have solved this on stream. I know I did a stream to explain binary lifting, but I don't know if it was this one. But okay, maybe I'll see tomorrow. For now, I'm gonna stay. I'm gonna keep it at 3. 3 is good for 2 streams, 3 problems. And this one is already. This stream is already 1 hour and 20 minutes. So I think this is enough for now. It's a good place to stop. Well, tomorrow is contest day, so maybe I'll do contest streams, and I'll continue with this series on Monday. Is there someone I could raid? Anyone doing LeetCode? Earthbean. Who is this guy? Well, he has only 1 viewer, so I'm gonna rate him. Great. Thanks. See you on the next one. Thank you. Earth. Bean. All right, guys. Thanks a lot. Thanks for the support. And see you tomorrow. Oh, the guy just went away. Anyways.